Okay, so there are also process that alkalizing the salts. Okay, this is the process where it consume the H plus or it's produce the OH or hydroxide. Okay, so weathering of non-acid cations from the minerals. Okay, so meaning that okay, remember that dalam in the structure of salts we have calcium, magnesium, and we have certain cations yang in the rocks. Betul tak? Dekat dalam structure rock tu. Okay, saya nak tunjuk juga. Apa ni soil structure ni bukan soil structure bukan soil crystalline structure. Okay, last time I showed you that the structure of the soil is like this, kan? So inside the soil there is an element of, for example, magnesium and calcium. What does it mean by my sentence just now is that the weathering of non-acid cation, for example here, the magnesium and calcium is also in the structure of the soil. So by time, okay, however it takes a very long time, by weathering process, macam batuan yang pecah, okay, the rocks that go through a weathering process, they will be released into the environment. However, this is it takes a very long time. Okay, so it is different from the cations that sit at the exchangeable site. Okay, so it's different. This is in the soil structure. So by time, by weathering process, this magnesium, for example, magnesiums or calciums can be released to the soil environment and it will alkalinizing the soils. There are also, okay, saya tunjuk you, this is some examples of soil that naturally has a high contents of calcium, calcium rich soil. Okay, so these are, if you see the whitish color, okay, the whitish color indicates that the soil has high contents of calcium. So by right, parent, it's the parent of the soil, which is the parent rock, okay, has high contents of calcium. So by time it released to the environment. So this, bila calcium they release, calcium brings pH yang tinggi. Okay, it brings alkaline properties. So by time it will alkalinizing your soil or neutralize your soil. That's why kalau when we want to neutralize our soil, we put calcium, okay, calcium carbonate. Mana tadi? Okay, so number 2 is the accumulations of non-acid cations. Okay, for examples, you are putting calcium and magnesium sources. Okay, one. Okay, then you are also putting that materials that have higher pH. Okay, for examples, yang ada, for examples, dolomite. Okay, dolomite contains of calcium and also magnesium. You put into the soil, so it will the magnesium and calcium will accumulate in the soils. Okay, productions of base producing anions. Okay, so sama juga excess of anions uptake by roots, meaning that the roots are taking up the nitrates. Okay, so when they are taking up nitrates, NO3 minus, they are releasing H, bukan H plus. Okay, kalau one cation equal to cations. Okay, but if the roots take up nitrates, so NO3 2 minus kan, so it will release the OH minus. Okay, so that is the process that alkalinizing the salts. Okay, oh ni yang saya nak explain ada dekat belakang ni. Okay, so these are some examples of weathering of non-acid cations from the minerals. If you can see here, first the soil is rich with calcium and silicate. Okay, so by time when there is a weathering processes, okay, so the calcium is released. So this calcium, tak nampak lah cursor saya. Okay, so this calcium will be contribute into the soil environment and it carries the alkaline properties. Okay, so some of the non-acid cations are released by weathering because X cations in the soil colloids. Okay, because uh, they are initially from the soil colloid, the structure of the soil, kan? Okay, so macam mana it can be released? That is because sometimes our rain has H plus. Okay, for example, acid rain. So acid rains by time dia akan weather the soil, weather the rocks. Okay, so the soil will become acidic if the leaching of calcium, magnesium, and potassium proceed faster than the release of the cations from the weathering of minerals. Usually, it will be like that. That's why soil are becoming acidic from time to time, bukan alkaline. However, it is also depends on the area. Okay, for example, in Malaysia, Mediterranean countries. Okay, kejap saya tunjuk. Soil calcium. Okay, so these are some of the in Mediterranean areas. Okay, so the accumulations of calcium in soil sebenarnya dia akan restrict juga the growth of the crops. Okay, because of what? Calcium is like the hardy material. So if it's too much, dia akan cause the soil to keras lah. Okay, the soil will be very hard and it's not suitable for the crops to grow. Okay, so everything nutrients have to be balanced. Okay, then, okay, accumulations of non-acid cations. Okay, so this is in non-region. Okay, in in Mediterranean area, for example, dry region, the mineral caused by the mineral weathering accumulate because there is no soluble water, there is no rain, so no leaching. Okay, that will also contribute to the accumulations of this calcium, sodium, and magnesium. This is a process of alkalinizing the soil. Okay, so if you want to compare when the soil is said to be in neutral conditions, okay, if you see here the pH of 6, the amount of the cations and also the amounts of the anions should be balanced lah. However, if you see at the left picture, okay, showing that the pH is 2, which indicates that the soil is acidic. Okay, so you see that the area of the cation exchange site are dominated with anions. Okay, however, if the soils have a high pH, for example, here is 8, it indicates that the soil cation exchange site were dominated with the non-acid cations, which is the cations lah. Okay, okay. When we talk about cations, dengar when we talk about cations, we have two types. For example, kita ada aluminium. Aluminium is positive, so it is cations. However, its characteristic is not basic ataupun basic cation. It is a acidic cation. Okay, usually the basic cation is only calcium, potassium, magnesium. Okay, these cations ataupun sodium, these cations brings the alkaline punya properties. However, H plus, aluminium, zinc, ferrum, okay, apa lagi ya? Chromium and all the heavy metals yang macam nampak macam like heavy metals tu, it actually is, we call it as an acidic cation. So remember, although it is an ion, although it's apa ni, cations, okay, you have two types. One is acidic cations, one is non-acidic cations. So acidic cation, for example, kita ada aluminium, zinc, semua tu. Okay, however, for basic cation, we have the most important is calcium, potassium, magnesium. Okay, and these are the nutrients that are needed by the crops. Usually, kalau nutrients that are needed in the crops, micronutrients too, they are needed in very small amount. That's why relate back to your pH of the soils. That's why you have to have like 6.5 to 7.5, slightly acidic conditions of pH, soil pH, because we want to make the micronutrients available for the crops. Yang ni okay, you see here, iron, manganese, boron, copper, zinc is also acidic. We call it as acidic cation because it brings the acidic properties. However, kalau dekat yang sulfur, calcium, magnesium, it brings a alkaline punya. That's why we call it a non-acid cations. Okay, so please be clear on that. Okay. Okay, so these are also the examples, okay, of productions of base producing anions. Okay, so in the basic or generating anions are principally carbonate and also the bicarbonate. Okay, so these anions are actually originate from minerals such as calcium carbonate. Okay, so calcium carbonate ni adalah, kita call it as a liming material. Okay, so liming material ni, the liming materials ataupun dalam bahasa Melayu we call it as kapur. Okay, so these liming materials are added to the soils to help to improve the soil pH. So how does it act in reduce apa ni panggil, increasing the soil pH? Maksudnya from acidic type of soils, we want to change it into a neutral soil ataupun a slightly neutral soil. Okay, so when we put the calcium carbonate, okay, so calcium carbonate is will be separated into two, which is it carries the cations calcium and also the carbonate. Okay, so this carbonate, when it added to with the H2O, which is the water, it will form what we call as a bicarbonate. So this bicarbonate and the production of OH negative, okay, so hydroxide, you can see that there is a production of hydroxide. This hydroxide is actually neutralizing the ingat kan, productions of OH negative tadi, neutralizing the soil, alkalizing the soil. Okay, so however, you can see here, this is a carbonic acid. However, it is a weak acid. Okay, so the weak acid will be changed into H2O. Okay, after a few reactions, okay, they akan change into H2O and also the carbon dioxide. Okay, so these two stage will produce two OH negative. Okay, from this carbonic acid with the additions of H2O also, they akan produce a carbonic acid. This is bicarbonate, this is carbonic acid. So when it produce the this, okay, this OH negative which I highlighted with red, this is the one which will change the soil pH, increase the soil pH slightly. Okay. Okay, so this will give the alkalizing effects. Okay, so yang tadilah meaning that it will neutralize the soil. Okay, so excess anion uptake by roots, this is the process yang meneutralkan tanah tadi. Okay, uptakes of anions. Okay, so the release of bicarbonates ion, okay, by the roots will give the alkalizing alkalizing effect. Okay, for example, nitrate are uptake by the plants and the root exudate the bicarbonates. Okay, so this bicarbonate produced by the roots will raise the pH of the soil. Okay, so in our region, okay, which is the humid region, okay, if you see here, okay, this is typical pH range of the soils. Most of our soil had pH of, sebenarnya kalau kat Malaysia it's around 4.5, okay, which is slightly strong acidic soil. Okay, in Malaysia kita ada what we call as acid sulfate soil. So acid sulfate soil ni memang because we have a coastal area. Sebenarnya kan saya cakap last time it was a sea. So some of the content of the parent materials ataupun parent rock has materials that brings the apa ni panggil acid punya component acid sulfate soil. Okay, so acid sulfate soil in Malaysia it is like this color. Okay, so asal dia it is from the lebih-lebih kurang macam ni lah. Okay, which asal dia daripada coastal area ataupun dulu-dulu last time it was a marine punya soil. Okay, so it actually it has a high contents of pyrite ataupun iron sulfide. Okay, so dia sebenarnya dalam bentuk yang stable, tapi by time dia akan brings yang kuning-kuning ni kan, you nampak kan, this is what we call as pyrite. Okay, so by time dia akan increase, dia akan naik ke atas. Okay, dia akan naik ke atas and it will lowering the pH of the soil. Okay, so this is more deeper which you will learn in if you take soil concentrations, okay, in soil management. Okay, up to here you have to know that in Malaysia we have this type of soil lah, humid region mineral soils. Okay, you can see it's slightly acidic. Kita kat Malaysia tak ada tanah yang banyak yang alkalino. We don't have problem with alkaline soil. Okay, however we have problems. Kita ada slight problems with calcium rich soil lah ada. Okay, so in acid pit soil the pH is even lower. Okay, and alkaline mineral soil which is in arid region usually is slightly towards alkaline. Okay. Okay, so faham any question? Okay, if you don't have questions, okay, we move to our next punya ni. Okay, so the rules of aluminium in soil additive. Aluminium ni, okay, it's very dangerous materials. Okay, however, okay, aluminiums are sekejap. Some of the soil have high aluminium, not all aluminium. That is because of their parents. For examples, soils that has high materials of aluminium is macam dekat bauxite soil. Sekejap saya tunjuk I show you aluminium rich soil. Okay, so when a soil is said to have a high aluminium, okay, that is because you can see from the color. Okay, the color is orange because it indicates the oxidizing effects of the materials of the soil. So macam ni you nak tahu tanah tu banyak aluminium, that is because of the red color of the soil which reflects that the soil has rich aluminium and also iron. Okay. Okay, so kalau in dalam bahasa Melayu, kalau mak-mak kita panggil tanah latrik. Pernah dengar tak, Mas Rizal? Syuhada, pernah dengar tak? Wan Nasrin, pernah dengar tak tanah latrik?
Pernah.
Pernah kan? Okay, so actually tanah latrik ni adalah tanah yang kaya dengan aluminium. Macam mana you nak tahu tanah tu nama dia tanah latrik? That is because of the colour of the soil. Okay, which it carries the aluminium content and also the iron content in the soil. Okay, so basically the problem with this aluminium soil is it has a aluminium inside the soil. So bila dia ada aluminium, it carries properties which we call it as the soil is very acidic and prone to what we call as aluminium toxicity. Okay, so laterite is a soil which high in ions and aluminium content. Okay, so it is mostly it can be found in a wet tropical areas which are like Malaysia, Indonesia, Sarawak. Also we can find this type of soils. Okay, so they develop by intensive and long lasting weathering of the underlying parent rock. Okay, so what is the problem here is that the roles of aluminium is in soil acidity. Generally, this type of soil, if you plant crops, okay, it's not easy to grow on crops on this type of soil. That is because of the pH problems. Okay, so the pH is where the H plus concentrations, but aluminium also play a role in acidity. Okay, sebelum ni saya pernah cakap kan, how you want to macam what is the criteria of acidic pH? That is because of there is accumulation of H plus, but there is also acidic salts that are contributed not only by the H plus but also by the aluminium element. Okay, so aluminium, if you see as I showed you before, the aluminium is a major constituent of most soil minerals. Okay, dia adalah dalam structure, so each of every soil structure mesti ada, cuma banyak dengan tak banyak je. Okay, so when H plus ion are absorbed, they did not remain silent. Okay, that's why if you have a soil pH, okay, soil pH you, please don't make your soil pH lower than 4. Okay, ataupun even 4.4, 4.5. If your pH is lower than 4.5 or 4.5, okay, meaning that the H ions are at your soil CEC site. Okay, generally H plus sit first, but this H plus usually did not remain silent. Okay, but this H plus will attack this H plus which sit at the cation exchange site. Okay, so this yang ni akan keluar dalam exam so please listen. Okay, so this H plus is sitting at the CEC site and it did not remain silent, it did not sit silent. However, it will attack the aluminium structure inside the soil structure. Okay, so how it attack, I will explain later. Okay, so they attack the structure of the minerals and it release, the aluminium is released to the soil environment. Okay, ingat, remember when you are determining your soil pH, it's not that you are determining the pH of the soil structure, tak. You are determining of the pH in the soil solution. Betul tak Iklima?
Betul.
Nisrina, betul Nisrina?
Betul.
Nisrina. Nurin betul Nurin?
Betul.
Okay, when you detect a pH, you detect pH bukan dalam ni kan ataupun dekat dalam the soil structure, but you are taking the soil pH. Meaning that sama juga if the conditions is in the field at your garden. Contoh saya nak bagi simple, it's in your garden. Okay, so when kat sini ada pokok for example this is pokok here. Dekat cursor, this is tree. My cursor is the tree. Okay, so when there is the root of the tree is actually absorbing the cations from the soil solution. Okay, while the soil is only hold the cations for a while. Maksudnya the soil just want to help to hold the cation for a while lah kan. Okay, so what is the important here is the soil solution. And if the H plus is a lot here, it will attack at the soil structure and it will release the blue color, aluminium, into the soil solution. Okay, so this aluminium can either be absorbed on the colloid exchange site. So aluminium can sit here also. And also aluminium can be released into the soil solution, which make this the pH of the soils even worse. Okay, so when the soil pH is low, terlalu banyak efek dia kepada crops and also nutrient availability. Okay, for examples, the root of the root of the crops ataupun your plant can be disrupted. Okay, so aluminium and H plus are considered as acidic cations. Remember that. Okay, so here the aluminium is actually playing two important roles. Okay, first, it is highly toxic to most organisms and plants. Most of organisms, including the microbes, tak tahan dengan aluminium. Okay, because dia punya properties which it carries acidic conditions and also it brings a toxic effect to the crops and also plant. Okay. And number two is that the Al3 plus. Okay, there are. Okay, saya nak cakap sini. When you talk about cations ataupun something like this, meaning that anion, cations, please remember if it is in the stable condition, contohnya aluminium, contoh dia, what I want to say, sekejap. Nak bagi contoh sekejap. Aluminium apa sekejap. Okay. Ni lah contoh dia. If it's in the forms of yang ni, tengok cursor saya ni, aluminium OH30 ni, which in minerals kita call it as a gibbsite. Okay, so this gibbsite is stable. Dia tak dangerous tau. Okay, but if it's in this form, it is very dangerous, meaning that it is mobile. Kalau dia dalam keadaan solid ataupun compound, it is stable. Okay, yang bahayanya adalah aluminium. Yang ni yang when it enters the aquatic environment, dia akan matikan haiwan. It will kill the aquatic animals. Okay, this form of aluminium. Not only aluminium, for other metals also. For example, zinc, copper, chromium. If it's entered the aquatic environment, it will kill the organism. It's in high concentration ataupun it can be easily accumulate in the body of the aquatic organism. But if it's in the form of like this, which is the stable, it is not dangerous. However, if you see here, the pH is very dangerous. Okay, pH will change from a stable compound of aluminium, not only aluminium, for other element also. Okay, maksudnya macam apa ni panggil, contamination that occurs in our environment kan, that is because the metals are mobile. What is a mobile metal? A mobile metal is in the form of like this. Dia dalam bentuk cation yang terapung-apung tu. Okay, so cations which is in the soil solution, which is not in the structure of the rock. No, if it's in the structure of the rock, yes. A rock or a soil is made up by the aluminium, magnesium, calcium. Itu adalah teras structure of the soil. But if the pH is, that's what I said, pH is master variable. It can change from a healthy or a fertile soil into a toxic environment because it can carries it can also carries and also contribute the heavy metals. Okay, so we don't want, and our action as a human, we naturally we will acidify the soil. Tengok kan, all the activities yang kita buat, yang saya cakap tadi, acidifying the soil. Okay, itu baru like generals. If we have intensive activities, for example mining kita exposekan tanah tu, we expose the soil to the weathering, to the even extensive weathering, we accelerate the process of weathering because of human action. Okay, so it will result in the release of the aluminium. Logic tak, Nurin?
Macam mana doktor?
Tak dengar lah tu. Tanya
Tak.
macam mana tu?
Sekejap, saya confused yang doktor cakap tadi yang bahaya aluminium yang dangerous to the plant tu, yang floating tu aluminium yang macam dia sorang-sorang tu
Dia aluminium yang sorang-sorang tu is Al3+. This
Okay.
one. Nampak kerja saya ni?
Sebab saya tak nampak kerja tadi.
Tak nampak? Tak tengok. Baca nota Cakap betul-betul.
Tak, saya tak nampak kerja.
Saya
Ni
pun tak
nampak.
nampak doktor.
Kerja tak nampak?
Kerja tu
Baru
gerak lambat.
Oh, okay ni Yang Al3+ ni yang jenis bahaya, okay? This is the dangerous. Tapi Al3+ ni dia bukan sengaja-sengaja dia duduk dalam environment. That is because by the human factors. Asalnya the original is like this. Nampak tak kerja saya? Lama ni pusingkan. Nampak tak?
Tak.
Tak
Kat
nampak?
atas aluminium tu ke?
Okay, sorry.
Dia tak gerak.
Ni
Tak gerak.
tak gerak. Itulah kan bila ni nampak tak? Okay. Cuba tengok yang bawah sekali. Kan? Ni Ya, saya buat ni. Nak bagi you nampak juga supaya you faham. Kejap. This is very important Okay, yang saya merahkan ni nampak tak?
Nampak?
Okay, sekejap sini saya buat. Okay. Sekejap. Okay, I repeat I repeat for you to understand. Okay, so if you see here, okay, tengok Ta-da! Okay, so this is the originals of the aluminium. The aluminium in this form, okay, yang saya terbangkan sekejap ni, okay. Okay, nampak? Nampak ke tak?
Nampak?
Nampak kotak merah ke patutnya?
Ya Allah, ya. Tak nampak
Tak
lagi.
ada.
Kotak merah tak ada.
Baru ada.
Oh, dia lambat dekat you. Nampak ni?
Okay, nampak.
Okay, so dalam bentuk ni ada aluminium. Aluminium ni dia in a mineral form. Dia mineral. Okay, so we call it as in a stable form of aluminium. So aluminium in this form is not dangerous. Okay, sebab before I teach you before this, the aluminium is compulsory to be in the structure of soil. Betul tak? Kan? Because it is a soil structure. It's a part of soil structure. So the problem is when if we change the pH by our human activities, for examples, we put fertilizer, acid rain, carb, then we put when all the activities that contributes to reducing the soil pH, the aluminium can be changed and to ni. Nampak dia terbang dah tu?
Belum.
Oh, kat saya dah terbang dah. Okay, dah.
Tak ada. Okay dah.
Lambat gila. Okay, so yang terbang nombor 2 tadi, okay, this one, the Al3 plus is the what we call is aluminium which is in ionic form. This is the toxic form of aluminium. Because why it is called toxic? Because it is very mobile. Dia boleh berenang-renang ke mana-mana. Okay, because it is dia cation ions. Bila kita cakap cation ion is moved by the water. It needs water molecules to carry it away. Okay, so, ataupun not only that, it can stay at the CEC side of the soil. So when aluminium, this Al3 plus sit at the CEC side of soil, so it reduce the potentials of the calcium, magnesium and everything to be seated at the CEC side. That is because the aluminium has highest affinity kan. Okay, so clear tak Nurin?
Clear?
Okay, so our activities can change. Okay, so dia taklah bertukar from this gibit side direct to Al3 plus. It change if there's pH 6.7, it will form into AlOH2 plus. Okay, when you ignore lagi pH you did not do you did not put liming materials, couple to improve the soil pH back to 7, then it will hydrolyze. We call it as a hydrolyze. With the additions of water, dia akan jadi AlOH2 plus. So when it change from here, okay, sekejap. Okay, nampak tak kerja saya?
Nampak?
Okay. So when it change from gibit side here to the Al3 plus, okay, dia akan produce what we call as a toxic molecules of aluminiums. However, not only that, it also contribute H plus to the soil environment. Okay, so dia macam like very dangerous that it acidify the soil 2 times. Okay, by the productions of acidic cation 1. Okay, so productions of ni lah yang saya bulat-bulatkan ni. Okay, and lastly Al3 plus, which is the most dangerous form of aluminium. And not only that, it also contribute H plus yang atas saya bulat-bulatkan ni juga. Okay, H plus ni maksudnya dia mengasidkan tanah. Okay, so what it will affect is that it will reduce the pH 1. Number 2, it can be tightly bond to the colloid negative sites. And these polymers is not exchangeable. Dia macam only aluminium sit at the CEC site. So there is no exchangeables of the cation. That is what happening in bauxite soil. Where saya tunjuk? Bauxite soil in Malaysia Okay, so this is bauxite soil. Nampak tak? Saya panggil orang nama saya tahu je. Sorry. Wan Nasrin. Nampak?
Nampak.
Mana nampak? Tak nampak saya buka ni tadi. Ifan nampak tak Ifan? Okay, Ifan nampak?
Nampak.
Okay, so this is bauxite soil in Kuantan. Sampai sekarang, kalau ni gambar ni dia ambil tahun 2014, sampai sekarang tanah ni macam ni. Okay, there is no lalang pun tak nak tumbuh. Okay, not even weeds want to grow here. That is because of the soil pH. When we talk about banyak, there is a lot of factors lah. But when we talk about pH here is that last time, okay, for examples, the aluminium is not at this, it's not available lah. Tapi when you are exposing the soil should be like this. Okay, sekejap Okay. Okay, the soil should have a cover crops on it. Okay, for example, the green one. Okay, but you expose the soil to the air, to the water. So you are accelerating the process of weathering. Okay, sebab tu pH you akan makin drop. Faham tak? Okay, so bila pH makin drop, dia akan make the aluminium available in the soil. So the CEC side of the salts are masked by the aluminium. No calcium can be seated there. For how long? It's already like 5 years. What is the action you can take to improve the soil? Okay, it's very costly. Dia melibatkan kawasan yang terlalu besar, berhektar-hektar. Okay. So that's the problem with this type of soil, which we call it as soils that have a very low pH and also high contents of aluminium. Okay, not only that. Okay, so sekejap saya tengok ni dulu. Okay, so this is the pH, okay, and versus the relative activity of the aluminium. Okay, if you see here, the most dangerous is the Al3+. Okay, so this Al3+ is the highest when the pH is 4. Okay, so if the pH is tak nampak kerja lah kan? Okay, nampak
Nampak.
Okay, so kalau pH dia 4 dekat sini, you see the Al3+ punya curve the highest is the at pH 4. But if the pH is like 6.0 or 5.5, the availability of the Al3+ are at minimal. However, dia ada dah yang ni, AlOH2+, but this is not as dangerous as this one and also this one. Okay, but if the pH is 6.5, you can see that only AlOH3 0, and this is not toxic at all. Okay, so as the pH decreased, okay, this is the toxic. This is toxic. Nampak Saya bulatkan. This is toxic. Kejap. Okay, can you see saya dah merahkan okay the toxic ni. However, it is by stage lah. This is the first stage, this is the second stage and this is the most toxic. Okay. Okay, ni sama juga. Okay, so this is when the soil pH is at low pH. Okay, so the exchangeables of aluminium will be high. Okay. Okay, so what will this aluminium toxicity do at your effects? Okay, what does this aluminium effects? Okay, we call it as aluminium toxicity. So any excess of this element, okay, will cause a toxic effect to the plants and causes multiple other problems. Okay, first for the plant, it can cause a direct toxicity. Primarily, we call it as a stunted root. Ada tak gambar? Okay, if you see here, this is the comparisons of 3 types of soil that has different pH. Okay, so this is the one with the lowest pH. Okay, no lime at all, no lime. Lime tu kapur Okay, maksudnya dia tak repair dia punya pH. The second one is that aluminium, pH of 5.1, okay, slightly higher lah. Okay, so if you see, if the pH is 4, tengok tak, dia punya roots are stunted. Okay, because of the roots are deformed. Okay, the roots did not favor the aluminium constitution. Not only that, but it also affects the other nutrients, the absorbance of other nutrients, the uptakes of other nutrients. Okay, so number two is that it also reduced the ability of phosphorus. Okay, so this phosphorus is very sensitive. Phosphorus are needed by the crops, kan? But when the aluminium are changed into cation, aluminium ni dia senang sangat nak bergabung dengan phosphorus. Okay, it tend to form with phosphorus and form a compound which we call is aluminium phosphate compound. So when these phosphate are tied by the aluminium, dia dipegang oleh this aluminium, and this phosphorus, when you, for example, oil palm required high contents of phosphorus kan, tapi this phosphorus is not available. That is because of the phosphorus are bound to the aluminium. Okay, so phosphorus tak boleh diuptake oleh that crops, that oil palm. Okay, because it's, as macam saya cakap, it's already tied bound by the aluminiums. It's in the form of compound. So when it's in the form of compound, it cannot be absorbed by the roots of the crops. Okay, so it reduce the ability of the phosphorus. Okay, so it will affect your crops. Your crops will be lack of phosphorus. Okay, number three is it reduced the availability of other nutrients cation. Okay, through competitive interactions, meaning that when the aluminium sit at the CEC site, it does not allow the calcium or the magnesium to be exchanged at the CEC site. Okay. Okay, macam saya cakap tadi lah, aluminium toxicity ada three types of species, which is the Al3+, OLOH2+, and also ALOH2+. Okay, kejap laptop saya dah habis bateri, ambil charger je. Okay, so there are a few factors, okay, of soil factors that contributing to the aluminium toxicity. Okay, so the availability of aluminium Al3+ is not completely understood, but certain soil factors are known to have a significant effect. Okay, so first, that is because of the type of the soil, which is I mentioned just now, the parent materials of the soils. Okay, for examples, in oxy soils type of soils has a high contents of aluminium. Okay, that is because of one, that the aluminiums are abundant in the soil. Okay, number two, if the soil pH drop. Okay, if it is said that if the soil pH is less than 4.5, the H plus will start to attack the aluminium structure in the soil. Number two. Number three is that the types and amount of clay in the soil. Okay, for examples, if because the clay, only clay structure has aluminium, correct? If there is a higher contents of clay, meaning that there is higher possibility of the aluminium in the soil structure. Okay, number two. Number three, it's a soil, or it also depends on the soil organic matter. However, it is said this is very minimal, okay, because of the pH dependent. Okay, the most important is number 1, 2, and 3. Okay. Okay, there are a few methods of determining or measuring the soil pH. Kita panggil, kita ada pH, the simplest one is pH meter. Number 2 is that you boleh buat dekat lab. Okay, macam yang saya tunjuk last week kan? Last week Okay, we do soil pH testing at lab, meaning that we use lab scale punya. Kalau pH meter yang macam ni yang kita guna at field, in situ data. Okay, but it's not very accurate. Okay, so however we have at lab scale yang macam you guna kan, even at lab scale pun we have 2 types. Satu kita guna water, one more kita guna calcium hydroxide kan. Okay, okay. Yang lebih lama adalah they use macam like a litmus paper, kertas litmus. Okay. Okay, so variations of pH at field. Okay, please remember that pH is very, very important at field, because once you have the value of the soil pH, you can expect what the soil can contribute. For example, if the soil is 4.5, okay, 4.3 lah. So you can expect that the soil is acidic condition and the nutrients might be restricted in that type of soil. So what will happen to your crops? Okay, when you plant a crop. Okay, so pH is master variables and it also determines the range of the microorganisms or microbes or bacteria or fungus that can live in that soil pH. Okay, because if the soil is like too acidic, for example, the pH is 4.3, not all organisms can be living in that conditions because they have restrictions in producing enzyme and also the metabolisms of physiological. It has physiological effects on their growth lah kan untuk microorganisms. And if it's too acidic conditions, maybe like the beneficial fungus cannot live in that range of soil pH. Okay, so soil pH can be varied spatially, maksudnya daripada one area tu it can patch lah, it can vary spatially, and also it can vary vertically. Maksudnya as it goes deeper into the soils, the pH will change, but it depends. Slightly the pH will be slightly acidic at the top because there is all the process of acidifying the soils happen at the top soil. But if it goes down, less activity in the soil kan. Okay, so activities that acidifying the soil, for example, microorganism produce organic acids, okay, decompositions of organic materials and all those things. Putting of fertilizer is only at the top. Okay, so any questions regarding soil pH? Ada soalan Zul Haris?
Doktor,
Ya, saya.
bukan soalan lah tapi nak tahulah.
Boleh?
Soil pH ni kan, katakan kalau land tu dia dah affected by aluminium kan, macam mana kita nak reverse balik effect tu? Like how do we?
Okay. So basically, saya rasa saya ada ajar kat dalam ni. Basically kita put liming, tapi when the soil is the problem is that how you want to eliminate the aluminium. Selalunya kita akan letak liming lah. For example, you put calcium carbonate in high concentration. So this calcium will replace the the place of the, kan aluminium tu dah duduk dekat tempat CEC side kan. So when we took calcium will replace. Sebenarnya tu je cara dia. Okay, am I answering you? Kita letak macam kapur, we call it as calcium carbonate. Yang lepas ni kita tengok lecture number 10. Sekejap tunjuk sekejap. So these are some activities lah. Sekejap. Sekejap tunjuk sebelum saya ajar.